We are going to do a question from the Cambridge past papers. This question is from May-June 2005, 2014, paper 42, question number 5. So actually this question is a motion of the objects connected by a string with the pulley, and we are supposed to do this question with the help of work and energy. We know that such question can also be done with the help of forces and Newton's second law, but here in this question it is restricted to do with the help of work and energies. So let's see the question. Here a light inextensible rope has a block A of mass 5 kilogram attached at one end. So this block A, and a block B of mass 16 kilogram attached at the other end here. So the rope passes over a smooth pulley which is fixed at the top of a rough inclined plane at an angle of 30 degrees to the horizontal. So at an angle of 30 degrees to the horizontal. So if we put this information on the diagram, so it has a weight of 16 kilogram is the mass, so the weight is 160 Newton, and this has the weight acting downward, vertically downward, which is 50 Newton. The coefficient of friction between block A and the plane is 1 over root 3. So it means that it's a rough plane. So this plane is rough. So coefficient of friction is 1 over root 3. So when we are doing this question with the help of work and energy, so then the tensions will be considered as the internal forces acting to the object. So those will not be considered while considering the forces, and the weight component will also not be considered, as it will be considered in the change in potential, gravitational potential energy. Okay, so let's start the first part of the question. They are saying that the block A is released from rest. So B is heavy, so it will move downward, and the weight component of this along the plane is quite smaller than the weight 160 Newton here. So that's why this object A will move up the plane and B will move vertically downwards when A is released from rest. So when each of the blocks have moved a distance x meter, each has speed v meters per second. So this information, if we show it on the diagram, so it means that this object A has moved x meters. So if it has moved x meter, it will reach to this point. So this is the object A after moving x meters on the plane. So this object B will move x meters down. So it will be somewhere here. So this part is x meters down from the initial position. So first part of the question is write down the gain in kinetic energy of the system in terms of V. So gain in kinetic energy we always do by change in the kinetic energy. Like we can say that change delta Ke in the kinetic energy is kinetic energy final of the system minus kinetic energy initial of the system. So since only two objects are moving, string is light, pulley is light and smooth, so only two objects A and B are moving. So the kinetic energy will be considered only of these two objects. So we can say here that this is equal to the kinetic energy of A plus the kinetic energy of B, the final one, minus the kinetic energy, this all is final, minus the kinetic energy of A plus the kinetic energy of B initial. So if you see the diagram, so here the speed of this is 0 meters per second, and here the speed of this is 0 meters per second because it is released from rest. Okay, so when it has covered x meters, so here the speed of this is v meters per second, and when it reaches here, its speed is v meters per second. So that means that this will be equal to kinetic energy of A will be half the mass of A, which is 5 times its speed v square, plus half mass of B into the speed v square. So this is the final kinetic energy of the system. So minus initial for A is 0 because the speed is 0, so everything will be 0, half mv square. So this will also be half mv square 0 because both release from rest. So then that means it is just a matter of simplification. So after simplification, this will be 5 plus 16 is 21 over 2 v square. So this is positive which we got. Why it is positive? Because v square. So square is always positive and this 21 over 2 is positive. So it's positive. Positive means that gain. So it means we can say that the gain in kinetic energy is 21 over 2 v square in terms of v. So this is the result of the first part of the question. So it will be in joules. So the unit is joules. Then the second part of the question is this, that find in terms of x the distance moved by both the objects. Number A, the loss of the gravitational potential energy of the system. So since it is already declared in the question statement that there will be a loss, so we are to find the loss in the gravitational potential energy, and then later we are to find the work done against the friction force because the surface is rough, so there will be a work done against the friction which is between the object A and the surface. Okay, so for part A to A, I have copied this diagram here. So here now if we see, we don't need the speeds here, so I'm erasing the speeds from here because that will confuse us in working with the potential energy. So we don't need these speeds. So rest of the information we need here. Okay, so see, the loss, as I told that we always take the change in the potential energy before we did the change. So kinetic with delta PE we will see here, change in the potential energy. So this is equal to the potential energy final of the system minus the potential energy initial of the system. So in other words, we can say that final potential energy means potential energy of A plus the potential energy of B final minus potential energy of A plus potential energy of B initial. So as we know that whenever we are doing a potential energy situation, so we have to declare that what is the zero level, like the level from where we'll take the heights of the objects. So let's say that this ground level we are taking as the zero level for both objects. So this is the zero level. So now initially the height of A is 0. It's at the ground level and height of B is not given. So we can also take this height as some unknown value h. So after covering x meters down, so this height of B will be now h minus x. And the height of A after moving x meter on the inclined plane, so the height from here to here, using this right angle triangle with this angle 30 degrees, this will be x sine 30 degrees. Okay, so now we have the initial and the final heights of both the objects, so we can easily calculate the change in the potential energy. So change in the potential energy will be potential energy of A final. So finally object A is here, so it means mgh of A. M times g we always take as 10 into height is x sine 30. This is potential energy of A finally, and plus the potential energy of B finally. It is here which has the height of x minus A, so we can say its mass 16 kilograms times g, which is 10, into h minus x. So this overall is the final potential energy of the system, and then we write minus potential energy of A initial. So it is at the ground level, so height is 0, so that means it will be 0. So minus 0 is the potential energy of A, this one, plus potential energy of B initial. Initially object B is here, so its height is h from the 0 level. So it means it will be 16 into 10 mg into height is h. So this is the final potential energy of the system. So now we will simplify it. So after simplification, we know it is 50 into sine 30 is half. So 50 divided by half, multiplied by half is 25x, plus this will be 160. So 160h minus 160x, and then minus this bracket, so it is also minus 160h. So here this term is cancelled with this factor, this term, both are same. So these are the unknown h which was not known, so it's cancelled out. So we got that the change in the potential energy is 25x minus 160x, so which is negative 135x. So since we got the delta PE negative, it means it's a loss. So it means we can say that the loss in gravitational potential energy PE is equal to 135x joules. So this is the answer for the second part A of the question. Now the part B of part 2. Find in terms of x the work done against the friction. So work done against the friction. We know that whenever some work is done by the force or against the force is asked, so first we'll see that do we have that force and do we have the distance covered. So then simply we use work is equal to force times distance. Okay, so here since friction force, so friction force is not given, but we have the information through which we can find the friction. So then simply friction multiplied by the distance moved x will be the work done against the friction. Okay, so let's do this part. So part B, friction force here will be, since the object is moving, so it will be mu r. So force of friction will be mu r. So mu is already given, which is 1 over root 3 in the question statement, times r. Here if in the diagram I show where is r, so r is here. We know that r is always perpendicular to the surface and out of the surface, from the surface towards the object, this way. So it is actually equal to the weight component which is acting in the opposite direction. So we know that this component is always 50 cosine of the surface angle, which is 30 degrees. If it is not clear, so remember that on some inclined plane, whenever an object is placed, so it will have two components. If the angle of the surface is theta, so two components will be one acting down the plane and one perpendicular to the plane and acting into the plane. So this is always W sine theta and this is always W cosine theta. So we don't need W sine theta, so we need W cosine theta to find the R. So that is actually this. Okay, so now coming back here, so it means R is equal to 50 cosine 30. So it means this multiplied by 50 cosine 30. So it means that if we simplify this, so cosine 30 is radical 3 over 2. Or you can use the calculator to find this whole quantity. So most of the Cambridge questions are designed in a way that we don't need the calculator. So root 3 is cancelled out, so it means it is 25. So 25 Newton is the force of friction acting to the object. So it means therefore the work done by the against the friction will be equal to force of friction multiplied by the distance moved. So force of friction is 25 and distance moved is x. So therefore we got the answer that these many joules, this is the work done against the friction. Okay. Okay, so then this question also have another part, which is the part 3 of the question. So that is show that 21v square is equal to 220x. So it means that by using the work energy equation we can show this, because the rest of the thing in this topic we have done with this situation. So if I write first the work energy equation here, so we know that work done by all the forward forces minus the work done against all the backward forces which are acting in the backward direction, is equal to the change in kinetic energy of the system plus the change in the potential energy, gravitational potential energy of the system. So we also know that while using the work energy equation, we don't consider the weight as a force on the left side of this equation, because the work done against or by the gravity is already considered in delta PE. Okay, so let's put the values here. Actually, in the previous part, we have calculated all these things in terms of v and in terms of x. So now let's put, since there is no driving force for both the objects, so the work done against the forward force is 0, minus the work done against the backward force is actually the work done against the friction, this one. So this value 25x we'll put here. So 25x, and this is equal to change in the kinetic energy, which we have found here in the first part, 21 over 2 v square. So putting this value here, and it's also important that if this delta K basically we are not thinking in terms of gain and loss. So that's why it is always convenient in our solution if we use delta K instead of gain and delta P instead of the loss or gain in potential energy. So we'll put this value of delta K 21 over 2 v square. So this substituting here, so it is 21 over 2 v square plus let's say which symbol is that. So delta PE we will see. Delta PE is actually minus 135x. If you see, this one we are calculating delta PE. So this is delta PE, which is minus 135x. So we'll not put that the loss is 135x. So we need to put the proper symbol with that, sign with that, negative or positive. So delta PE is minus 135x. So that's why it is negative 135x. Okay, so now just in one step we can simplify this and we will get this thing which they are asking to prove. So this one we can move to the left side. So it means it is 21 over 2v square is equal to, now it's only the matter of algebra. So 135 will become positive. So 135 minus 25 is 110. 110x, and now taking this 2 to this side, so it will become 220x is equal to 21 v square. So see that this is 2 marks part, so therefore it is proved that 21 v square is equal to 220x. So it is proved. Remember, there will be no marks of writing this because it is already given in the question statement. So the marks are till this step, these 2 marks. Okay, so this is the question which we have solved. Hope it's clear to all of you.